This is my 8th video lesson for the covalent bond unit, and this lesson will be describing metallic bonding. Let's go to page 28 in the class packet. Motivation. View the physical properties of the metals below. Why do metals have these properties? So here are 5 properties of metal. So in order to understand why metals have these properties, you need to understand the structure of metallic bonding. So we're going to discuss that in this lesson. Learning target. At the end of the lesson, I'll be able to identify and explain properties of metals and metallic bonding. Homework number 8 will be a junior part based off this lesson. The next exam will only be on Unit 5B, the covalent bond. In order to figure out the properties of metals, we need to first figure out the structure of metallic bonding. Here we have potassium atom. It has one valence electron. In a sample of potassium metal, there are a lot of potassium atoms. So where is the attraction or the metallic bonding? In order for there to be an attraction, opposites must attract. So what opposite charges do you see here? We see the nucleus and the electron. The metallic bonding must be between the valence electrons and the nucleus of each metal atom. So the dashed line represents the metallic bond. Each electron can move around and bond with neighboring metal nucleus. It is similar to how pollen moves from one tree to another tree. The electrons are basically like the pollen. They can move from one metal nucleus to another metal nucleus. So how will you describe this structure? This is best described as a sea of electrons. Metallic bonding is the bond between metals. The attraction is between the metal ion's nucleus and the sea of mobile valence electrons. Mobile means the valence electrons are moving, they are delocalized. The reason why they're delocalized is because of the low ionization energy of the metals. It doesn't take a lot of energy for the electrons to be removed from the metal and move around. Here's a diagram showing the metallic bonding that occurs in metals. It typically includes the metal's nucleus, which is positively charged, and the electrons, which are negatively charged, that are mobile, that are moving around. Here are the properties of the metals. They are shiny, high conductivity to heat and electricity, they're malleable, they're ductile, and they're hard. So why do metals have these properties? In order to explain it, we need to look at the structure of metallic bonding. So before we do that, I want you to watch a video about metallic bonding. The link will be in the descriptions. Once you watch it, resume this video. So I assume everybody has watched the video. I'm now going to review the video and explain why metals have these properties using the structure. Why are metals shiny? So from the video, light is much more easily absorbed by free mobile electrons, which goes to the excited state. And once it goes back to ground state, it releases light, giving the metal a shiny appearance. Why are metals good conductors of heat? So from the video, when a metal is heated, the free mobile electrons absorb the energy, then move faster, raising the temperature of that metal. Why are metals good conductors of electricity? So from the video, when electrical current is applied, electron repulsion pushes the mobile electrons, generating a current. Why are metals malleable or ductile? So from the video, metals can be deformed because the mobile sea of electrons shield the metal nucleus from each other. So the metal nucleus will not repel each other because they're being shielded by the valence electrons that are mobile. Why are almost all metals hard solids at STP? So from the video, metal cations can be tightly packed because of the mobile sea of electrons. The only exception is mercury, which is a liquid at STP. Learning check number 1. What type of bond is found between atoms of solid cobalt? Pause the video and resume once you complete it. So cobalt is a metal, so it has metallic bonding. Choice 3. Learning check number 2. Which factor distinguishes a metallic bond from an ionic or covalent bond? Pause the video and resume once you complete it. So metallic bond have mobile sea of electrons. So choice 1. Learning check number 3. Metallic bonding occurs between metal atoms that have what? Pause the video and resume once you complete it. So metals have unfilled energy levels and low ionization energy. So choice 3. So this is a summary table of the ionic, covalent, and metallic bonding. Use this to study for the exam. The table shows the properties of each type of bond, as well as a model and some examples. Learning check number 4. Which of the following solids has the highest melting point? Pause the video and resume once you complete it. The first step is to figure out what type of bonding is present in each compound. H2O has covalent bonding, Na2O has ionic bonding, SO2 has covalent bonding, CO2 has covalent bonding. We know in general ionic compounds have a higher melting point than covalent compounds, so the answer is choice 2. Learning check number 5. Which substance contains metallic bonds? Pause the video and resume once you complete it. So metallic bonds is only between metal and metals. So which one is only metals? That would be choice 1, mercury. Learning check number 6. We are given a table containing compound A, B, C, and D and their properties. Which list identifies the type of bonding characteristic of each compound solid phase? Pause the video and resume once you complete it. So the answer is choice 4. Compound A has high melting and boiling point. It conducts electricity as a liquid and is soluble in water. It has ionic bonds. For compound B, it has high melting and boiling point, does not really conduct electricity or soluble in water. It is a network solid. Compound C has low melting and boiling point. It does not really conduct electricity or soluble in water. It is a molecular substance or has covalent bonds. Compound D has high melting and boiling point and conducts electricity and is insoluble in water. It has metallic bond because it is a metal. This concludes the video lesson for today. Remember to do the Junipod homework.